Alkynes are unsaturated hydrocarbons having the general formula CnH2n-2. Let's see how we can form different alkynes by using different methods. Let's start with the first alkyne, which is ethine. The common name of ethine is acetylene. Let's look at the laboratory preparation of ethine. We can prepare ethine by the action of water on calcium carbide. So we have water. We add calcium carbide to it. So you see bubbles of a gas rising and a white colored solution being formed. The presence of the gas is tested in this manner. It catches fire. That means it is a combustible gas. So the gas released in this reaction is C2H2, which is acetylene, which was seen through the bubbles rising. And since it is a combustible gas, it catches fire. So we use calcium carbide. We make it react with water. The white colored solution that was formed is calcium hydroxide, and the gas released is ethine or acetylene. Which reagent is made to react with water to form ethine in the laboratory? So during the laboratory preparation of ethine, we use a reagent known as calcium carbide. When CaC2 or calcium carbide reacts with water, it forms a white colored compound known as calcium hydroxide, and a combustible gas, that is ethine or acetylene, is released. Another way to prepare ethine is by using the dehydrohalogenation method. From the name itself, we see it's the removal of hydrogen and the removal of halogen. As we had seen in case of alkenes, we use a very special reagent known as potassium hydroxide in the hot and alcoholic form. So when we use KOH, it is made to react with 1,2-dibromoethane. When it reacts with this, it forms ethine. The bromine, in this case, goes with potassium. It forms KBr, 2 molecules of KBr. And at the same time, the hydrogen atoms are removed. Since it is dehydrohalogenation, the hydrogen atoms react with OH to form 2 molecules of water. Now let's see how this reaction is taking place. We have 1,2-dibromoethane. We make it react with hot and alcoholic potassium hydroxide. So when it reacts with KOH, this has a special property. It leads to dehydrohalogenation. So now 1 hydrogen from this carbon and 1 bromine from this carbon. Similarly, 1 hydrogen and 1 bromine from the other carbon is removed. Now, this carbon is short of 2 single covalent bonds, and this carbon is also short of 2 single covalent bonds. So, in order to satisfy its tetravalency, both the carbon atoms now form a triple bond. So, as 1 hydrogen and 1 bromine atom from both the carbon atoms is removed, in order to satisfy its tetravalency, now the 2 carbon atoms form a triple bond between them, and this is how they form ethine. So by dehydrohalogenation, that is by the removal of hydrogen atoms and halogen atoms, in this case we have used bromine. So in the presence of hot and alcoholic potassium hydroxide, by using this method, we can form the corresponding alkyne. So the process remains the same for all the alkynes. So in this case, we have used 1,2-dibromoethane. If we have to prepare propyne, we use, instead of ethane, we use the appropriate propane reagent and so on. So the method remains the same for all the alkynes. So by using dehydrohalogenation, that is in the presence of hot and alcoholic KOH, we can prepare the appropriate alkyne.